Hello everyone, welcome to another video. Now, we are continuing with this idea of parallel and perpendicular lines in the Year 10 Linear Relationships course. I've talked at length about what it is with two lines in the previous year's content. What is it about these lines that makes them parallel or perpendicular? And in this video, I just want to take those ideas and just apply them at working through some harder questions, and particularly towards the end of the video, these very tricky end of exam type abstract questions we may encounter, or you may encounter. Now, we defined two things about parallel and perpendicular lines when we talked about this in the Year 9 course. So for parallel lines, our gradients were equal. So the gradient of one is equal to the gradient of the other. This way they can move in the same way and never touch because their slope is identical. Now for perpendicular lines, we noticed that when we multiply these two, so m1 times m2, we're going to get -1. Or we also wrote this as m1, for example, is the negative reciprocal of m2. Squeeze in this 2 here. So these are the two main definitions we're going to be working through in this video. The idea that parallel lines are equal, well, the gradients of parallel lines are equal, and the gradients of perpendicular lines are the negative reciprocal to one another. Or that when we multiply the gradients of perpendicular lines, they should give us -1. So we're just going to jump straight into some questions now. We're going to do some warm-up questions and then do some trickier ones right at the very end. So here we want to find the equation of a line that is parallel to y equals minus 4x minus 1 and passes through the point -1 and 3. So let me just quickly write on here. I have an x coordinate of -1 and a y coordinate of +3. Okay, so when you encounter this question, you will want to, instead of just jumping straight in, because this is what I notice a lot of students do, they'll just go straight in, start like substituting these points, and they don't really know what they're actually doing. So when we approach any of these types of questions, particularly with parallel and perpendicular lines, we want to pause for a minute, go back to these two definitional things we talked about earlier in the video, and think about how we can apply these. So we have a line of y equals -4x minus 1. So the characteristics of this line, we know it has a gradient of 4 and it has a y-intercept of -1. Or this b. So y equals mx plus b. And what I'm going to do, because that equation definition is so important, I'm even going to write that on the side here. All lines we can express through this gradient intercept form of y equals to mx plus b. Now, this is where we pause, because we want to read and underline the question. We want to underline the key points. So we want to find the equation of the line that is parallel to y equals -4x minus 1. There's a lot of, and we have, passes through -1 and 3. Well, the point -1, 3. So we want to identify the important parts here. We know that this line is parallel. My new line is going to be parallel to this one. So my new line is going to have an equation, some equation of y equals to mx plus b, but we know that its gradient is equal to this line that I've written here. Now, what do we know about parallel lines? We know that the gradients must be equal. This line is parallel to y equals -4x minus 1. If it's parallel, its gradient must be the same. So I don't have to do any calculations just yet. I can just substitute in right off the bat a gradient of -4 into my new line. So my line that I'm looking for, I already know it has a gradient of -4. And now I just want to find my intercept of B. So we've ticked off, we've applied this one important point from the question, and we have another one we have to consider. It passes through the point -1 and 3. It passes through the point -1, 3. So these are x and y coordinates of some point. Now, if you remember everything we've been doing with linear relationships up to now, as well as we talked about this in the previous video, when we know that a point is on a line, or that a line passes through a point, these values of x and y, when you substitute them in, they're going to make an equation. So they are going to make this equation true. So when we sub these in, these make our equation true. So in other words, when we substitute this in, we can say for sure that our left-hand side is going to be equal to our right-hand side. This equality will happen. And if this is equal, then we can rearrange the equation to get to my intercept B, my missing unknown piece. So what we're going to do is we're going to substitute -1 in place of the x and 3 in place of the y. So I'm going to have 3 on the right hand side equals to -4 times -1 plus b. I'm just substituting the x and y coordinates of the point into my equation here, and this makes it a true equation. So what allows it to do that is, because it's now, this becomes an equation where this is equal to, the left hand side is equal to the right hand side, I can find my intercept here. I can find my unknown by solving the equation. So -4 times -1, that just gives us 4, +4 plus b. And now to solve the equation, we just want to get b on its own. So we're going to subtract 4 from each side and to balance this equation, and that gives us b on its own on the right. And we get -1 on the left hand side. So that means our equation, we have a value of b and we have a value of m. So we can just substitute that b straight into here. So we can say now, therefore, y equals to -4x minus 1. Okay, cool. So, interestingly enough, what we got subbing back in is the exact same line, which can be an answer. By popping this in, a parallel line can be perpendicular, two lines can also be parallel if they're exactly the same line. Now, this is a bit of like a trivial sort of solution, but it is a solution nevertheless. Hopefully for this next example, we'll actually get a different line, hopefully, so you can see this idea a little bit more clearly. So, for this next part, we want to find a line perpendicular to this equation that I've got here and passing through 4, -1. Okay, now once again, we want to consider all of the points here. So this is perpendicular So because we're given the information that this new line we want to find is perpendicular to y equals 2 over 3x minus 4, all I need to get from this perpendicular statement is that the gradient I'm looking for is going to have a relationship with 2 over 3. It's going to be the negative reciprocal of 2 over 3. So therefore, the gradient of my new line is going to be, well, the reciprocal of 2 over 3 is 3 over 2, and we want the negative reciprocal. So I'm going to pop a negative sign in front of here. So just by considering the gradient of the line I'm given and the idea that my new one is perpendicular to it, I have half of my question done. My y equals to minus 3 on 2x plus b here. I can just substitute in my gradient right into the m of my equation of a line. Because remember, all lines are given by y equals mx plus b. We have an m, we can substitute it straight in. And in the same way, we're going to use this point now in order to find b here. So because this line passes through this point, I can substitute the x and y values into this equation. So I'm going to get negative 1 equals to minus 3 over 2 x plus, whoops, instead of the x, I can put 4 plus b. Okay, so I get negative 1 here. So minus 3 on 2 times 4 is going to give me minus 6. And I have plus b here. Okay, now I just want to get to b. So I'm going to solve this equation by doing this opposite operation to give me b on its own. And I'm going to get that b equals to 5. And thankfully this time it is a different line. So here my equation now, so we can say therefore y equals negative 3 on 2 plus, x plus 5. So for these types of questions, I am just using the information that I've been given, and I'm always consulting my two definitions on parallel and perpendicular lines. These types of lines have relationships based on their gradient. So the main thing that's going to tell me about this line is going to be, obviously, the gradient. That's the very first thing I'm going to do. And then once we're given a point, we can just substitute this point into the x and y and solve the equation to find what our intercept would be. Now you can graph these two lines if you'd like. Y equals 2 over 3x minus 4 and y equals negative 3 on 2x plus 5 onto Desmos, and you will see that these two are parallel. They, sorry, not parallel, these are perpendicular. They're going to cross and meet at 90-degree angles. Okay, now, one major idea that I'm trying to get at here is that we want to be working smarter, not harder. Before we go into any calculations, we're considering the definitions first. I had to do no working out in order to get this, basically. I just read off my definition of a perpendicular line. So we're going to be applying this idea to two final trickier questions here. And the reason I'm going to give you these questions is because these are harder, more abstract questions. And all of these end of the exam harder questions, they usually have a couple of things in common. They are always abstract, so not just something that you can obviously just go in and calculate. They require a conceptual understanding of the topic, as well as for you to work smarter, not harder. And hopefully these next couple of examples are going to give you an idea of this. So here I want us to find a if y equals 1 minus a over 2 x plus b is perpendicular perpendicular to y equals 1 on 2x minus 3 on 5. Now, what I've noticed in my years of teaching and tutoring is that when students encounter questions like this, they immediately panic. They don't know where to start. They start just jumping in with random calculations and just throw things at a wall and see if they stick. Now, what we're going to do here is we're going to consider the definitions we learnt once again. And we're going to realize that a lot of the information here is irrelevant. This is just an abstract question that requires us to consider the concepts. So, the main thing we are given here is that we want to find A, and we know that this equation that I've given, this line y equals 1 minus a over 2x plus b is perpendicular to y equals half x minus 3 over 5. What do we need to consider here? We need to know about perpendicular lines. So we're only concerned, even though this is a b, we don't care about that. We don't care about this thing over here. We're only concerned with the gradients and what A is, because the fact that these are perpendicular lines tell us that there is a relationship between the gradients. So this is that m1, m2 equals -1, or that m1 is the negative reciprocal of m2. That is all we need to know. We are working smarter here, not harder. We're just using our conceptual understanding. So, okay, I have that this is perpendicular to this second line. So I already know what my gradient has to be. I know that my gradient must be the negative of my line. So my gradient 1 minus a over 2 is equal to the negative reciprocal of a half. And I can calculate this. I can say, well, m1 times minus a half equals to -1. So I can solve this by just dividing both sides by -1/2. So dividing -1 by -1/2, that's going to give me my gradient as +2. Another thing we could have done is we could have gone, well, the 1 over 2, the reciprocal of that is 2 over 1, or just 2, and stick a negative in front of it. Now, I know that this gradient, that 1 minus a over 2 equals to 2. Equals to 2. And now I can just solve this equation. I can times by 2. So I get 1 minus a equals to 4. And I'm going to subtract 1 from each side. I get minus a equals 3. Therefore, a equals -3. We are working smarter, not harder here. The only thing I had to do was to consider the gradients here and the gradient relationships. Now, one more quick question. Another thing you may get is that the lines, for example, y equals 6 minus 2x. Let's do a different pronumeral. 6 minus 2y. No, let's do a. 6 minus 2ax plus 5 and y equals 4a minus 3x plus 3. You will get given that these two lines are parallel. Find a. So find 2a if the lines are parallel. So what are we going to do? All we need to do is consider the two gradients. Now, these two gradients, if the lines are parallel, they are going to be equal. So these expressions, the coefficients of x, are just the gradients. So I can set these two to be equal to each other. So I have 6 minus 2a equals to 4a minus 3. Because the lines are parallel, so their gradients are equal. Now it's just a matter of solving the equation. I'm going to add 2a. So I get 6 equals to 6a minus 3. And I can work my way to an answer. So just working through this quickly, I can divide both sides by 6. That gives me 9 over 6 or 3 over 2. So all of these questions, we are working smarter, not harder. The only thing you need to do when you approach something like this, it looks a little scary, pause for a second and consider the two definitions we talked about at the start of the video. These two, the ones that where parallel lines have equal gradients, perpendicular lines have gradients that are negative reciprocals of one another, those are the only two things you need, as well as some other linear relationships understanding. But you can now work through some really abstract questions with ease. But thank you so much for joining me in this video, and I'll see you in the next one.